Now let's see what we get. Can anyone plug it in? Is 5 in the domain of this function? It's okay if you're wrong. Just interact with me and your colleagues, please. That's the whole purpose of being here. And it's okay if you're wrong.
No.
It's not. Very good. Awesome. 5 is not in the domain because it creates a denominator 0. Exactly. So then we know that this is no hope situation. Okay. So the numerator, I hope you agree, is positive. Now I would like you to plug in, instead of 5 from the left. So remember, if this is 5 from the left means 4.9. 5 from the right means 5.1. So at this point, since it's 5 from the left with numbers smaller than 5, I would like you to plug in 4.9 and only tell me the sign of the answer. I don't need the calculation. I only need the sign.
Wouldn't that be negative?
Excellent. Remember, no hope example or situation has 3 options. We have to choose from these 3. Either infinity or negative infinity or DNE. It cannot be DNE because we are only looking from one side. We don't know what's happening on the other side. So it's not this. Which of these 2 will you pick based on positive at the top and negative at the bottom? Anyone?
Negative
Infinity. That's it. That's it. Exactly. So this is an example of no hope. And we had so many other different examples: rationalizing, simplifying, factoring, when x approaches infinity, and so on and so forth. So in this situation, when x approaches infinity, if the function approaches a number, that is the horizontal asymptote. So y equals 1/3 horizontal asymptote. And here, when x approaches 5 from the left, and the function goes to negative infinity, x equals 5 is a vertical asymptote. As you see, multiple examples. They're all different. Okay, so back to the book. I wanted to show one more example, and then I wanted to talk about continuity. So an example like this. So these are a little bit more sophisticated. I don't think that this is really, I'll show any example you want, but I would like to present a simpler example than this. So let's say we have limit as x approaches 1 from the right, from the square root of x plus 2. In this situation, for this problem, we have to find a domain. What is the domain of this function? We discussed this last week. For this particular function, what do we have to state and solve to find the domain? I'm going to write it here on the side. What do we have to write to find the domain? Anyone remembers? We discussed this and we had multiple examples with the square root. What do I have to write to find the domain?
X plus 2 is greater than or equal to 0.
Brilliant. So x greater than or equal to -2. So the domain is -2 to infinity. Thank you so much. Now, if this number is in the domain, just plug it in and you're done. Is this number in the domain?
Yes.
Yes. So plug it in, drop the limit operator because we are applying it, and give me the answer.
Wait, would it be the square root of 3?
That's it. Done. Good. Next, we want to talk about something called continuity. Continuity, a function is continuous if I graph it without lifting the marker off the paper. This is a continuous function. What about this one? Is this function continuous? Can I graph it without raising the marker off the paper?
No.
No. This says a jump, discontinuity. Discontinuity. Jump discontinuity. Perfect. What about this one?
No.
Absolutely not. This one is called infinite discontinuity. And there is one more. It's called removable. The last one. Last type of discontinuity. Removable. So let's analyze this situation. So at this point, let's say 3, 5. At this point, is this function continuous?
Yes.
Yes. Continuity at a point. Here is what is required for continuity at a point. The limit from the left must equal the limit from the right and also equal the function value at this point. How do I write this? Limit as x approaches a from the left of the function equals the limit of f of x as x approaches a from the right and must equal f of a. This is the definition of continuity at a point. Again, what does it mean? One more time. Limit from the left of 3 equals the limit from the right of 3 and also equals the function value at 3. So this is a totally new concept. Now I'm saying to you the limit equals the function value for continuity. They are different concepts, but the limit from the left equals the limit from the right and equals the function value if the function is continuous at that point. I'm going to share my screen. Now let's take a look. Where is this function? Determine whether each of the functions shown is continuous over the interval -6x. So between -6 and 6, I would say even easier. Where is the function not continuous? Where is 47? Function from 47 not continuous.
-2.
Exactly. Where is this function not continuous? So it's continuous everywhere. And we say it's continuous from the right because the limit equals the function value at that point. It's not continuous from the left because the limit from the left does not equal the function value at that point. Oops. So 49 is continuous everywhere. It doesn't have a jump, it doesn't have an infinite discontinuity, and it doesn't have an open point or removable. What about 51? Is 51 continuous everywhere? You may be muted, you may be talking. Is 51 continuous everywhere?
No.
Where is not continuous and what type?
At -2.
Yes. And the type of discontinuity is? What is it? It's called infinite discontinuity. What about here? Is this function continuous everywhere?
Yes.
Careful, very difficult to see. There is an open point here. So this function is not continuous at -1. What type of discontinuity is it?
Removable.
Perfect.
Discover.
Perfect. Awesome. It is removable. Okay. 57. Is this function continuous? Is 57 continuous? Please.
No.
No. Where is not continuous and what type?
3.
At 3
And
is
it's a jump.
a jump. Awesome. And it's continuous from the left. Okay? Because the limit from the left is 1 and the function value is 1. But it's not continuous from the right. Okay. I wanted to look at the cost. Okay. So we have the function. They are giving us the graph. Can anyone find the limit from the right of 2? The limit from the right of 2. How much?
Is it 1?
Yes. The limit from
1?
the left of 2.
-1?
Perfect. The limit from either side of 2. The limit from either side of 2.
Does not exist.
Excellent. C of 2. C of 2.
One.
Exactly where the full point is. Awesome. Awesome. Well done. Thank you. Thank you. Thank you. Okay. Good. I'm satisfied so far. Now look what is the next section. Our best friend, which we already discussed. We didn't wait. We were very anxious to talk about it. So we can directly, I have the page number. What is the page number? Directly, I copied it, 133. So I have nothing to say about this section. You can teach this section to me and to everybody else. Okay? This is it. We discussed that in the last 2 weeks. Okay, so anything you want? So here, all these problems, 37 to 44. Use each graph to estimate the average rate of change of the percentage of new employees in that type of employment from 2008 to 2012. From 2000, no. Just choose one. They're all the same. Which one would you like to look at? 2008 to 2012, 2012 to 2017, or 2008 to 2017? Choose one. Any of those three ranges. Which one?
Let's do 2008 to 2012.
The first one. Very good.
Yeah.
2008 to 2012. Very good. So let's look at total employment. So 2008, very hard to read. 2008, can anyone give us the Y value here? I don't think it's 0. It appears to be 0, but I don't think it's 0. So, and this is percentage change. So it's not 0.5. I'm going to say 0.2. So 2008, comma 0.2. Let's see where 2012 is. Let's read the point. Very difficult to read, but easier than the other one. 2012, I would say 1.5. So 2012, 1.5. Good. So they want us to determine the average rate of change. How do I write the average rate of change? Y2 minus Y1 over X2 minus X1. 2012 minus 2008. The numerator is 1.3. The denominator is 4. Or 13 over 40. Multiply top and bottom by 10 to eliminate decimal numbers inside a fraction. And now we have to write the measurement unit. Percentage change over year. So percent change per year. And yes, we can calculate an approximation of that. We could do that. What is it? 13 divided by 40, 0.325. So 0.325 percentage change per year. And that's it. That's all we're asked to do. Find the average rate of change, which is the slope of the secant line, if you want. Okay. Total cost. Suppose Fast Trends determines that the cost in dollars, C of X, of producing X iPod holders is given by: find C of 305 minus C of 300 over 305 minus 300 and interpret the significance of this result. Okay, so C of X, and that's 51. C of X is negative 0.05 X squared and plus 50X. And they want us to find C of 305 minus C of 300 over 305 minus 300. What do you think this is? What would that ratio represent? So I have negative 0.05 X squared. You know me, I prefer to look at the function. I don't want to do this by hand several times. I just want to plug in quickly 305 and 300. That's it. So I want to look and see these are integers. That's fine. So 10599 minus 10500 over 5. So the numerator is 99 and the denominator is 5. Measurement unit, always measurement unit. We can't, right? So cost in dollars, and X units. Okay? So this is dollars per unit. 99.5. So, what does it represent? Can anyone tell us what does this represent? 99 divided by 5. Anyone? Dollars per unit. 19.8 dollars per unit. What does it mean? It's the average rate of change between manufacturing 300 and manufacturing 305. The average rate of change of cost per unit is 19.8. I have another discussion for you. I would like us to work on this.